fashion between two devices as we see here. Where technologies such as spanning tree are implemented, you will find certain links will remain redundant in the network to prevent switching. Another factor is that this takes up port space within the device, however, this will remain unutilized. As networks become ever more demanding, the throughput of these networks will slowly increase with the strain of bandwidth utilization. The concept of link aggregation represents an effective way without requiring the equipment to be replaced at extra cost to the organization. With Ethernet networks, the process of Ethernet trunking is performed that bundles multiple Ethernet links to operate as a single Ethernet pipe. It is capable of supporting close to the sum of their total bandwidth combined. We represent here how the communication between the two switches in the form of switch A and switch B is supported by the bundling of multiple physical links into a single logical Ethernet trunk. The implementation of link aggregation solutions is a congregate such as the aggregation of the enterprise. As traffic flows to and from those end stations, services and resources, it will pass through essential parts of the network, and if the networks are not well structured, will result in bottlenecks that slow throughput and possibly even cause loss of data. From the example, we can consider the traffic can be shared between switch C and switch D, as well as between switch A and B, so as to reduce any likelihood of network congestion. The implementation of link aggregation supports two modes. These are understood as manual mode and LACP mode. As the name suggests, the manual mode allows for port interfaces to be manually associated with an Ethernet trunk. These port interfaces are known as member interfaces and will operate as a single logical interface as part of a link aggregation group. These member interfaces will be set to operate in a forwarding state and will perform load balancing of frames over physical links based on certain criteria, including the forwarding of frames with the same source MAC address or destination MAC address, or based on the source or destination IP addresses, for example. This helps to ensure frame order is maintained over the Ethernet trunk. The alternative is the use of a link aggregation control protocol, or LACP. The LACP mode enables links to operate with active links and backup links in the event that the active link fails. This helps to ensure that consistent bandwidth is maintained over the Ethernet trunk, even in the event of link failure. In this section, however, we focus primarily on the Layer 2 manual link aggregation mode. For the operation of an Ethernet trunk to be successful, it is necessary that all member interfaces that make up the trunk be consistent. This includes the number of physical interfaces that are supported between the peering switches. Configured parameters such as the duplex mode and transmission speed must also be the same to prevent frame loss during operation. The Ethernet trunk should also not attempt to use a mix of Layer 2 and Layer 3 interfaces. There is also a threshold for manual-based link aggregation, which determines as to how much bandwidth is supported over the Ethernet trunk. This is limited based on the number of member interfaces currently in an up state, and also by a maximum number of up member links parameter that ensures reliability based on sufficient bandwidth. With consideration of the principles covered, we can begin to look at the process of configuration of the manual mode Ethernet trunk. We give a basic example here involving two switches in the form of switch A and switch B, with two links that are to become member links. Of configure this using the interface Ethernet trunk command, with the one here in this case referring to the instance of the trunk created, to which all member links are to be associated. Under the physical port interface view of the switch A in this case, we then bind the respective port interfaces to the created Ethernet trunk, for which trunk 1 is referenced in all cases, to ensure that all interfaces are bound as member links of the same Ethernet trunk. The logical Ethernet trunk will operate by default at Layer 2. Where routers are used, however, the Layer 3 based link aggregation is recommended to be used, to allow the logical trunk port to function as a route port. This is set using the undo port switch command, followed by which an IP address can be configured for the logical route port, which in this instance has been assigned as 100.1.1.1/24 on RTA. In this manner, the aggregated link will continue to function as a common link with increased bandwidth and support redundancy. As with the Layer 2 Ethernet trunk, the relevant physical interfaces must be associated with the logical trunk. In using the display interface command followed by the name of the logical interface that has been created, we are able to determine the current state of the interface, as well as the physical port interfaces bounded to support the port aggregation. It is necessary to ensure the state of the logical link trunk interface is in an up state, which may be affected should some problem occur to any of the physical member interfaces. The current status shows that both member links are present and active as part of the Ethernet trunk. So we come then to the summary for this section, in which we have a couple of questions. The first asks, if an administrator attempts to add a gigabit Ethernet and fast Ethernet interface to the same Ethernet trunk interface, what will occur? Well, member interfaces of different types are not supported by the Ethernet trunk, and therefore any attempt to associate a gigabit Ethernet and fast Ethernet link with the same Ethernet trunk would result in an error being displayed in VRP, notifying that the trunk has added a member of another port type. In order to establish backup member links, which mode of link aggregation should be used? Well, backup member links are only supported through the LACP mode, since if we recall, all member links in the manual mode are set to forwarding. This section looks at link aggregation that acts as a mechanism for better utilization of redundant links. So as a means of optimizing the throughput of data, link aggregation enables the binding of multiple physical interfaces into a single logical pipe. This effectively introduces solutions for providing higher utilization of available links, as well as extended resilience in the event that failure of individual links were to occur. Engineers are required to have a clear understanding of the conditions that define the behavior of link aggregation and the skills and knowledge for its application to ensure effective link aggregation solutions can be applied to enterprise networks. So upon completion of this section, it is generally expected that trainees will be able to explain the use of link aggregation in the enterprise network, describe the various forms of link aggregation that are supported, and configure link aggregation solutions. The use of redundant links within the enterprise network may involve connections in a point-to-point fashion between two devices as we send switching loops. Another factor is that this takes up port space within the device. However, these ports will remain unutilized. As networks become ever more demanding, the throughput of data for networks with slower links may begin to feel the strain of bandwidth utilization. The concept of link aggregation represents an effective way of making full use of redundant links and also providing to the overall bandwidth, without requiring the equipment to be replaced at extra cost to the organization. With Ethernet networks, the trunking is performed that bundles multiple Ethernet links to operate as a single Ethernet pipe. It is capable of supporting close to the sum of the We represent here how the communication between the two switches in the form of switch A and switch B is supported by the bundling of multiple physical